Let's start today's session. And today we will explore the third session of the AIDT course, its application to smart cities. This session will show how AIDT can transform urban to make them more efficient and sustainable. Yeah, so our objective for today are multifold. First, we will dive into the core concept of AIDT and this role in smart cities. And we will then explore the various real-world applications, highlighting how this technology reshape urban management and service. And following that, we will discuss the AI and the machine learning algorithm in optimizing these AIDT applications. And finally, we'll talk about the challenge and opportunities that lie ahead in this dynamic field. Yeah, in this session, I'd like to encourage you to ask a question, share the insights, and think about how this concept apply to the world around us. Okay, and as we know, AIDT involves a simulation process that integrates physical model, sensors, and operation data. This process creates a virtual mirror of the physical contact, reflecting this entire life cycle. And the core elements of AIDT include the physical entity, vertical models, data, and AI models, like the connection and the service. Yeah. And then let's understand what we mean by the smart city. This urban area leverage the technology, data, and intelligent design to improve the quality of life, efficiency of the service, and sustainability. And in the content of AIDT, smart city become dynamic system able to adapt and evolve in the real time. So at the heart of smart city is the concept of AIDT. This involves creating a digital replica of the physical city in elements, like from the buildings and the infrastructure to the transportation system and the energy grid. These digital counterparts are not static, they are dynamic models that constantly learn and update themselves. So the digital twin city is a broad application of the AIDT concept at the city level. It's aimed to build a complex mega system in which the physical world and the virtual space are mapped onto each other and interact in both directions. It can match the physical city with the corresponding twin city, forming the patterns of coexistence and integrate between the physical city in the physical dimension and the digital city in the information dimension. And AIDT Smart City cannot be built without a strong data formation. This requires large amount of urban big data collected daily from the sensors, the camera, and the various digital subsystems spread across the city. This data point provides the real-time insight into how the city is functioning. And the technical foundation of the AIDT Smart City, which include the cutting-edge technology such as the Internet of Things, cloud computing, big data analysis, and the AI, as well as the latest advance in 5G. This technology work in harmony with each other to process, analyze, and utilize the data collected to make city more efficient and responsive. Like in practice, in practice, the AIDT Smart City bring many benefits. It's increased the efficiency of the infrastructure management, like optimize the deployment of the city resources and improve the overall process of the urban life. So the 5-dimension model proposed by Tao and his team enrich our understanding of AIDT in smart city. The model includes the dimension of the physical entity and the virtual entity, digital twin data, service system, and connectivity, the 5-dimension. And this is important to recognize that AIDT are constantly evolving and the characters vary depending on the stage of development, the specific application, and the user requirement. So in the urban context, the AIDT city show 4 main characters: the accurate mapping, virtual real interaction, software definition, and intelligent feedback. These characters provide the basic for how the digital twin city operates and interact with the physical city. The first is the accurate mapping. That's involved comprehensive digital modeling of the urban elements like the road, bridge, and buildings. This is achieved through the extensive sensor networks, providing a dynamic and detailed digital representation of the city's physical state. And for the virtual real interaction, that means every observed tracing in the physical city, from the movement of peoples to the flow of the vehicles, can be reflected and searched in the virtual model at the same time. This interaction allowed for real-time monitoring and analysis of the urban activities. And then is the software definition. That's referred to simulate urban life and events in the digital twin, like using the software platforms. This approach allowed for experimentation and scenario testing in a risk-free virtual environment. And next is the intelligent feedback. That involves using the AIDT for planning, simulation, and early warning of the potential urban issue. These provide actionable insights and solutions to enhance city management and public service. And the final, the integration of the technology such as the IoT, cloud computing, big data, and AI is also crucial in AIDT cities. This technology not only supports the operation of digital twin cities, but also guide and optimize the planning and management of the physical cities. So our first use case example of AIDT in smart cities focus on the smart city operation brain that can say SCOB. This innovative system acts as the central nervous system of a smart city that's integrating and managing various urban functions and data streams. The SCOB operates under a complex management structure as shown in this figure. The leader is the Chief Operating Officer, that's supported by the Chief Information Officer Joint Conference Committee. The SCOB oversee 4 key urban information sectors: the urban IT operation, the maintenance, big data center, urban operation monitoring and the command center, and the smart service center. The main function of the SCOB includes the participate in the top level city design, planning, information development, formulating the policies, integrating urban information resources, and monitoring city operations for the efficient cross-department coordinate. And the core of SCOB is the Public Information Cloud Service Platform. As shown in this figure, this platform performs the infrastructure of SCOB, comprising the layer of infrastructure, software development, and application layer. It enables city officials to manage a smart city function effectively through the various applications. And the platform creates an ecosystem that includes the data collection, processing, storage, and application. It serves as a resource pool for the urban big data and a hub for the urban IoT, commanding and monitoring city operation. And as shown in this figure, a multicultural urban command and emergency center can be created by integrating data from a cloud data center and a digital subsystem. Across the department, the center use data analyze IoT sensory and real-time monitoring to improve the urban efficiency and reduce the cost. And in short, the digital twin enables the smart city operation brand reflect how digital innovation can simplify the city management, like improve the emergency response and optimize city service. And here is the next use case. Like we will explore the smart grid digital twin. This is a multi-dimension simulation process that leverage the physical model, real-time data, and history operational data of the power system. This integrates various disciplines like electricity, computing, economic to mirror the smart grid life cycle in a virtual space. As shown in this figure, the expansion of the grid size, like together with the natural disaster and the deterioration of the equipment environment, has increased the pressure of the grid inspection. Like the traditional manual inspection are become less efficient and cannot meet the growing demand for the grid maintenance. So therefore, the digital twin technology provides the solution. As shown in this figure, like the digital twin enables the development of the real-time insulator damage detection and AI-driven tree barrier safety distance calculation. This approach transformed grid detection, making this more efficient and effective. The use of digital twin in the smart grid enables the continuous detection, accurate failure interpretation, and automate reporting the failure. And this significantly reduce labor intensity and improve the overall reliability and the security of the power infrastructure. So The next use case is bring us to the smart city traffic brain, a revolution application of the AIDT in urban traffic management. This system harnesses the power of big data generated from the various sources like the mobile phones, cameras, like the public transport and mobile apps. A prime example is the Wuhan Road traffic smart and emergency system as shown in this figure. This system is crucial component of the Wuhan smart city traffic brain. It integrates multiple network resource and real-time dynamic traffic information, connecting with the various emergency plans for a comprehensive traffic management solution. And this system deeply integrates the source such as the police, road condition system, accident response system, and the traffic video system. This integration enables a uniform interface for the monitoring and managing the urban traffic scenario. And as the core of this system is the management of traffic big data. It utilizes innovative congestion index evaluation, which leverage this algorithm leverage the historical data and the current traffic flow and the vehicle speed information. It's allowed for accurate assessment of the road congestion level, like real-time ranking the congested road and compare analyze between the historical and current traffic condition. And this system offer function like video verification, security management for major events, real-time scheduling, navigation, and playback for the congestion event. Its feature provide a robust decision-making mechanism for traffic for the traffic authorities to effectively address and mitigate the traffic congestion. Yeah, that's also combined with the intelligent traffic cloud and the geographic information system can revolutionize the urban traffic management. It enhances the decision-making process, like easily case the traffic congestion and help to achieve the smoother and safer urban mobility. And the fourth use case I want to talk about is the smart city public epidemic service system. This is a crucial application in the realm of public health management. As shown in this figure, this system utilizes a cloud data platform, analyze system, response system, and user determines to manager and response to epidemic effectively. And the core of the system is the patient's temporal database, formed by fusing hospital patient information with spatial temporal trajectory data from communication operators. This comprehensive database is the foundation for tracking and analyze epidemic spread. And the epidemic big data analysis system employs spatial temporal proximity analysis and AI to identify the epidemic occurrence and trace close contact. The findings are then communicated to the response system for swift action. And the response system plays a key role in connecting government agency, like the deployers and the individual user, is provides crucial data for outbreak control decision and employee health status and personal self-isolation guideline. Yeah, and the AI location intelligent technology enables this system to trace historical data, identify the high-risk area, and assist in virus transmission dynamics and analyze, as shown in this figure. This allows for detailed disease traceability and risk warming to citizens entering the high-risk area. And this system also supports global integrated the grid prevention and control. That's displaying epidemic spread at the various geographic level and monitoring key population movement for real-time epidemic situation update. So in the contents of the resuming work and the production, the system manager company declares and reviews, ensure the compliance with the epidemic prevention measure and providing early warning for any abnormalities. And the next use case focus on the flood monitoring and the flood situation service in smart cities, like leverage AIDT. This system offers the comprehensive solution for management the flood disaster, covering the entire life cycle from the pre-disaster monitoring to post-disaster reconstruction, as shown in this figure. The system comprises these three main components: the normalized and dynamic big data monitoring of flows, and a flows knowledge map, and flow service application. These components work together to provide a robust response to flood-related challenge in the urban area. And for the first component, flood big data monitoring involves the real-time collection of flood-related data, ranging from water condition in the river to dynamic trajectories of people and the vehicles. This achieved use ground sensor, satellites, remoting sensory, and IoT technology. You can see this figure. The construction of the flow knowledge map is based on the big data analysis and AI. It facilitates the inference and the discovery of knowledge related to the flow dynamics, adding in effective decision-making during the flow event. And with the flow knowledge map, the system can provide smart cities flow service application. This application include real-time simulation of the urban flow scenarios, knowledge mining and modeling, as well as the flow disaster prediction and management. And you can see it's a planning response strategy and managing the overall flood situation. And additionally, feature of the system is the public opinions analysis, as shown in this figure. This helps to understand public opinions on the flood prevention and contribute to smarter and more responsive urban planning. So in conclusion, the smart city flow monitoring and the flow service system show the potential of AIDT to enhance urban flood response. By integrating the big data, AI, and real-time monitoring, it helps a comprehensive solution for flood disaster management in the smart city. And here is the one example that I received a lot of example of the smart city digital twin shared by Gerardo this morning. And he has worked a lot of projects related to the smart city, and it is very interesting, such as this figure. It is the Smart City Intelligent Operating Center in Beijing. The whole area of the roads, traffic, vehicles, and emissions, and even the environment can be monitored in the real time. This is very interesting example. And thanks for sharing, Gerard, and looking forward to the final session that you can give us a great presentations. And next, we will focus primarily on a use case that's very related to us, the digital twin smart city for citizen feedback. This paper describes the development of a digital twin model for the Dublin Dockland. This is a very good example of how digital twin can directly involve citizens in shaping their own cities. And the Dublin Dockland digital twin was created with multiple aims. This includes the visualization, future urban development, modeling the potential urban scenarios, and the most important, creating a platform for citizen feedback and participate in urban planning. Let's have a look the design of a digital twin smart city. And we will explore the 6 layers of the smart cities that from the foundation of the model, each adding unique and crucial information to create a comprehensive AIDT. As shown in this slide, our digital twin model consists of 6 layers: the terrain, building infrastructure, mobility, digital layer or smart city, and virtual layer or digital twin. These layers works in harmony, building up each other to form a complete digital representation of the city. Okay, the first layer of the digital twin smart city design is the terrain of the city. This is the basic information about the city, such as which part of the city is near the sea, which there are river or canals running through the city, and which part of the city is standing, and which part of the city has poorly drained soils that could cause problems such as the landslides or heavily rains or floods. This soil map shown in like this figure can be used to incorporate this information into the model. And next is the building layer, incorporating highly accurate 3D model of existing construction. In our Dublin Dockland case, they use detailed building information modeling, the BIM, and aerial photography to create this model, providing a realistic views of the city's architecture landscape. And for the layer 2, the infrastructure layer, adds the essential elements like the road, power supply, and the telecommunication network. that's sourced from the OpenStreetMap and the 3D mapping. This layer ensures that our AIDT reflects the true operational framework of the city. So the third layer of the AIDT Smart City model adds the mobility to the infrastructure and building layers. Mobility refers to the movement of the people on the daily journey and the movement of the goods that assist them in different aspects of their lives. And the software applications such as the Sumo can be used to simulate urban transport. The Sumo simulator supports a number of different models and of the transport, like walking, cycling, and the vehicle, and other models available include the railway and the waterways and so on. And the other software, we can use the Unity to implement and enhance the traffic models, adding additional behavior nodes modeled by the simulator. In this example, like adding the multiple pedestrians type, the people's type, such as adults and seniors, like the children and so on. So for the layer 4, the digital layer or smart city is a data center. It collects data from the IoT sensors that monitor everything from the traffic to utilize and contribute greatly to the real-time digital representation of the city. And the digital layer of the smart city is responsible for collecting all the data required for simulation in the virtual layer from the previous layers. The result of this simulation will be feedback as information to the various layers of the city. This data can come from the citizen, the device, and the assets, which may be like the mobile and distribute all over the city. That citizen can use their mobile phone and smart watch to report data to the city authorities. And the top of the Dockland digital twin model is the virtual layer and the digital twin. Here, data from the previous layer are combined to simulate and analyze scenarios such as renewable energy project, building construction, and urban policy. And this figure shows that of the online digital twin interaction, we can see that citizen feedback can easily obtain from the model deployed online via the internet. The feedback can then be sent to relevant groups, such as the researchers developing models of the urban mobility or city councils, providing data on urban IoT. The city councils can then use the data to make informed decisions about the urban planning and the policy. And the key stakeholder for each component of the online digital twin are also shown, with blue box indicates the main technology that's used. So each layer of the digital twin smart city plays a vital role of creating a dynamic, interactive, and realistic presentation of the urban space, like for innovative and citizen-centered urban planning. So let's have a look at the application of the doubling AIDT model. One application of the model is the skyline simulations. It helps to visualize the impact of new buildings on the city skyline. User can walk around in the digital twin to see how new buildings will change the view from different location. Like this image shows a comparison between the current views of the harbor area available in the Google Map and the current mock-up. As we can see, the current view in figure A differs from the modeled view in figure B, with many of the buildings still under construction. The digital twin makes it easy for citizens to see what the city will look like in the future, and this building can take years to complete. Yeah, and this image show that proposed building extension, which will change Dublin's skyline. Like figure A shows the current city model, that figure B shows the proposed building plan. This allows cities officials and members of the public to easily walk around the city and identify some of the problem that a large building such as this may have in the city, such as the blocking sunlight or mobile phone tower that allows any complaints to be heard before the construction on the building begin. And the digital twin also helps with the green space planning. It uses smart city data such as air and noise pollution to identify the best location for parks and the recreation space to improve the city life. Like figure A shows a simple demonstration of the park created in the city center that serves as a recreation space for residents and workers. The number of citizens use the park can be tracked using the sensor in the smart city. With the digital twin available, online user can provide the feedback by interacting with the model and leaving the suggestions. This could be placement of the new benches like the tree, plants, or outdoor park fitness equipment. Sensors in the smart city can be used to track engagement with the additional equipment. And the figure B shows a smaller green space created in the city by planting some additional tree. Modeling using data from smart city can ensure that the tree receives the right amount of sunlight, the temperature, and water throughout the years. Residents can also provide feedback by choosing from a short list of trees suitable for the area. And interestingly, in these figures shows the result of the feedback on additionally items that should be included in the new park. The table presents 3 options. There's more benches, more summer flowers, and park fitness equipment. Another switch option for children's playpens was suggested by users on the form and then added as options, making this second most popular option. And this encourage citizen participate as they can see that options are changing based on their feedback. And the most popular option was park gym equipment, which may be due to the park's location in the financial district and the employees wanting to the exercising freely. And another innovative use is the user tagging. Yeah, this feature allows citizens to tag real-world problems such as the broken street lights or litter. This AIDT model, and then report them to the relevant authorities. And this figure shows a user interacting with a street light in a 3D model. By interacting with the street light, the user has the opinions to report problem such as the light not working or the light turning on when it's still bright outside. This report can then be sent to the city council to solve the issues with a detailed report of the actual location and problem that need to be addressed. Yeah, and like this map shows the user tagged feedback collected in the simulation. We can see the series of user tags in the top left-hand corner of the map to report later issue in the area. This can then be reported to Dublin Litter Wonders and environmental health officer with the extra location of the problem. And the digital twin also very useful for the emergency simulation, as they can simulate events that really occur. This image shows a simulation of the flow scenario in the harbor area. This simulation is able to show how the rising water level of the river will overflow into the surrounding street. Like from the figure A to F, we can see how the increase in water level could lead to greater damage, and how each area of the city center would be damaged. And this information can be used to effectively place the sandbox and other flood countermeasure to protect the most at-risk areas. Yeah. So each of these simulation provides interesting and valuable insight for the urban planning. They highlight the versatility of the AIDT in adapting to a range of urban challenges, from the architecture to the emergency response. Yeah. So having explored the Dublin Docklands digital twin and the various other smart city use case, we are now understand how digital twin presentation and improve the urban planning and the citizen engagement. So let's talk about the most important component of the digital twin is the machine learning and AI algorithm. Yeah, this algorithm plays a crucial role in processing and analyze the vast amount of data generated by the urban environment. Like we can see, machine learning and AI algorithms are adept at handling the big data landscape of smart cities. They process sensor data, user interaction, and other urban metrics to provide the predictive insight. These insights are essential for urban planning, resource allocation, and emergency response strategy. And AI algorithm enhance urban service by predicting traffic pattern, like optimize the public transportation routes, managing energy consumption, and improve public safety. They allowed for dynamic adaptation of city service to meet changing the demand and the condition. And also the intelligent feedback mechanism in AIDT cities often relies on AI to analyze various urban scenarios. This analysis help city administrator make informed decisions about the urban development, sustainability, innovatives, and the resource management. So the algorithm act a catalyst in AIDT cities, driving them toward more efficient, responsive, and smarter urban ecosystem. As this technology continue to evolve, they will further enhance the capability of digital twin for smart city planning and management. So we will start to talk about how to choose the suitable AI and machine learning algorithm. Yeah, selecting the right algorithm for a smart city application involves several key factors. They will explore these factors to understand how they affect the effectiveness of the smart city solution. The first is the type and amount of data available in the smart city have a significant impact on the choice of the algorithm. For example, large amount of structured data from sensors are best analyzed using the decision trees or regression algorithm. Conversely, unstructured data like the traffic camera image, they maybe require deep learning methods like the CNN and RN. And the amount of data also determine the feasibility of the central algorithm, such as some algorithm requires more data to be effective. And the trade-off between accuracy and speed is also crucial. In scenarios where a decision needs to be made quickly, such as the real-time traffic management, like the fast algorithms such as K-nearest neighborhoods may be preferred. However, for the long-term urban planning, like we need more accuracy, but slower algorithms such as random forest and gradient boosting may be more appropriate. And the next factor to consider is the complexity of the problem at hand guides the choice of the algorithm. Like simply problem may only require the basically statistical algorithm like the linear regression, while the complex problem like the prediction urban utility demand pattern, like to recognize the pattern, may require the neural network or the machine learning or deep learning models to capture the non-linear relationship in the data. Yeah, so algorithm selection is not a one-time decision. It's an ongoing process that involves iterative testing and improvement. As smart city grow and more data is collected, algorithm must be continually re-evaluated and updated to maintain the effectiveness and efficiency. So in summary, selecting AI and machine learning algorithm for smart city is complex and a dynamic process that depends on various factors such as the type of data, the required accuracy, the complexity of the problem, and the need for continuous improvement. Making the right choice is crucial to developing effective, sustainable, and responsive urban solution. Yes, and as we conclude, this is reflect on the challenges and opportunities that come with the complementing AI and AIDT in smart city. This understanding is crucial for navigating the future landscape of the urban technology. So the one major challenge is the technology complexity and the need for advanced infrastructure, ensuring robust data collection, storage, and processing capability is crucial. There are also the challenge of integrating the disparate system that technology to work seamlessly together. And also we need to think about the data privacy and the security. With the vast amount of the data collection, city must implement strong data protection measure and address the privacy concerns of the citizen. And also we need to think about the ethical consideration, including the bias in AI algorithm and the digital divide pose significant challenge. Ensure the access to the benefits of the smart city technology is essential for include urban development. Yeah. And also we need to think about the financial and the resource constraints that hinder the implementation of this technology, developing the cost-effective solution and sustainable funding models is crucial for widespread adoption. Yeah. And despite these challenges, the opportunity are also immense. AI and AIDT can revitalize urban planning, enhance the public service, improve the sustainability, and foster more responsive and resilient cities. So, looking ahead, we anticipate continuous innovations in AI and in AIDT. Yeah, these advantages will further empower smart cities, driving more efficient urban management and improving the quality of life for the residents. Yeah, so now let me turn the mic over to Ali Riza. He will talk in more detail about the AI and machine learning algorithm.
Yeah, thank you very much, Yulin. It was fascinating use cases of AI digital twin in smart cities, and that's really interesting to see how this technology can help us in our cities, how to predict the things, and different aspects of that could be seen, in terms of predicting the things, in terms of visualization, in terms of feedback reporting, and so on, and even generating the feedback reports for what is going on and so on. So it was really interesting, and like we discussed in the beginning of the course, the plan for each session is to review the use cases and critical points in a specific area of the AI digital twin. This week, actually, we reviewed the use cases in smart cities to give us a little bit of overview, what kind of the application it can have, And if we have some idea in our industry, in our business and so on, how we can start developing a use case to implement AI digital twin to do something significant for us. It could be very, very simple use case. It doesn't need, for example, in the Dockland, you could see it was really complicated, a lot of details and so on, several layers and so on. It doesn't mean necessarily AIDT could be really complicated and complex to cover a lot of different aspects. We can consider only a few different situations and scenarios. If just small, niched, and focused problem to solve using AI digital twin. And sometimes also we can focus on the bigger problems. For example, at DCU, Dublin City University, that's a few years, they have started developing a digital twin to show lifestyle and life at the campus, DCU campus, which is really interesting to see how different facilities around the campus are available, how students are and people and staff, everybody is interacting with the facilities and so on. So that was the first thing we covered in this session. And the second thing, Yelin actually reviewed in the previous session, we reviewed as the key points, we reviewed the objective setting. And in this week, actually, Yelin reviewed the, selecting AI and machine learning algorithm, which is really, really crucial and important. Yelin actually reviewed all the key points there, so I don't want to repeat them, but I want to just say it is really up to your problem. It doesn't mean necessarily we should select the state of the art and the most craziest algorithm everybody is using, or nowadays everybody is talking about generative AI or talking about large language model, and it means if you want to develop any specific AI digital twin, we need necessarily to follow those trends and try to select the machine learning algorithm from one of those state-of-the-art topics. If it is implied, if it is required for our project, of course, it is a good idea to look for something from the state-of-the-art. But if our algorithm can be, address our problem, can be addressed using some sort of simple decision tree or regression AI machine learning algorithm, that should be okay to select them. And we should consider all the factors. It's not like the best algorithm ever is the best choice. No, the infrastructure, the budget, the data that we have. Sometimes there are good algorithms, but they cannot support the data that we have. Sometimes the privacy stuff force us to select a specific machine learning and AI algorithm and so on. So that's really important aspect. And like Yelin mentioned, it is not just one-time decision. We can come back to it and make a lot of other stuff. Okay, let's finish it here and let's start the most interesting and fun part of the course, which Yelin wants to run it again. That's the quiz time. So let's see what type of questions Yelin has developed for us for this session. We're excited to see what are the questions and how she wants to challenge us. Okay, so please join us by scanning this QR code again. What is the question, Yelin?
Yeah, it's a true or false questions. Is smart cities utilize AIDT exclusively focus on the development of new infrastructure without considering existing urban elements? Is true or false?
Okay, 8 people have replied, 9 people. Let's give more time. That's interesting. Smart cities utilizing AIDT exclusively focus on development of new infrastructure without considering existing urban element. That's a good question. So actually, when we develop AI digital twin, we have a lot of already existed resources. Everybody thought it is false, which I think, yeah. So we can, of course, in the Dockland AIDT use case, again, as you could see, we had the virtual layer, which was where, and we had what was the layer before the virtual? It was the digital layer where we had all the data, algorithms, and so on, processing power. So when we use the existing urban element, that's one of the challenges, how to, integrate them into the digital nature of AI digital twin. Okay, let's jump to the next question to see what is the next one.
Yes. Next one is, which characters is not a part of smart cities based on the AIDT?
Accurate mapping, virtual, real interaction, software definition.
Yeah.
Okay.
And
9.
let's see.
Give it a little bit more time. Yeah, to see. Okay, seems like everybody has selected the answer.
Yes. Yeah. Everybody knows the answer. Yeah.
Very good. It was very straightforward question. Very good. On digital advertising.
Yeah.
It's really misleading. Okay, let's see the next question. What could be the next one?
Yeah. What role does AI play in a digital twin smart cities? A meaningful entertainment purpose. B, to simulate and predict urban scenarios. C, to create digital artwork. D, to enhance online shopping experience. Yeah, that is a simple question, I think.
Okay, so perhaps everybody should be okay. This time, Yellen, you have simple questions.
Yes, yes.
I hope you have a challenging question too. Okay, the next one to see what is the next one.
Yeah, is what role do IoT and cloud computing plays in the smart city with AIDT? A, only for entertainment purpose. B, supporting data storage and processing. C, exclusive use in online shopping. D, only for social media integration. Yeah,
Yeah,
that's also is
yeah, again,
similar to the previous one.
yeah, okay. You had a simple question. Okay, we need to challenge audiences with more complicated question next time. Okay, let's see the next question. I think the next one is the last one. See what is the next question, and hopefully this one is more challenging.
Which is a challenge faced by the smart cities in implementing AIDT, A, ensuring all citizens have social media accounts. B, balancing technology innovations with data privacy. C, only focus on the digital entertainment. D, pre-processing digital art creation.
Yeah, again, I guess everybody would answer this question. 100.
Yes. Yeah,
Correct.
because I want to show that AI and like IoT and cloud computing and the challenge we faced implementing the AIDT is important to as a reminder. Yeah.
Yeah, exactly. Very good. Okay, so that was the quiz part, and I think we are kind of the end of the session. And I'll leave it to Yelin to say the last word. And if you have question, of course, you can ask a question now, and you can ask the question along the way also, if you have any question. We hope in the final session, which is in January 11th, like we rescheduled the final session. Some of the people joined a little bit late to the class, so let's tell we have canceled next Monday. Instead, we will have session number 4 on next Thursday, and 5th session would be next year in 11th of January to provide people more time for the homeworks, etc. And the deadline for the homework would be 22nd of December. We can finish it. Go
Yes.
ahead.
Yes. Yeah. And the assessment, like Alriza said, is true. Yeah.
Go ahead. I don't know what was the noise.
Is to complete the first 3 sectors in your respective spreadsheets in the different group. Yeah, this is the homework.
Yeah, please feel free to, work on the questions for these 3 sections, and answer the question. And if there is any question, anything you want to receive help from us, please mention us on the cell you're working on and make a comment there. So we'll come back with the reply and so on.
Yes.
Okay, I think we can finish the session.